So can we start?
Okay, sir.
Yeah. Thank you. So is my voice audible to all of you clearly?
Yes, sir.
Yeah. Thank you. Good morning, all. So today we'll be discussing on the topic of NoSQL databases. Actually, two terms are there. As you know, you are having this topic in your syllabus. So from the theoretical point of view, what exactly the NoSQL means? The term concept related to the same. What is the meaning of NoSQL? How it is exactly emerging? What is the usage of NoSQL in current world in information technology companies? Apart from that, which different kind of NoSQL databases, data structures are available, their applications, their architectures, their usabilities, along with the methods like the sharding technique, replication methods, cap theorem. This term we'll be talking about in detail first of all, and after the concepts of NoSQL databases are over, we'll talk about the MongoDB as a case study. Okay, how can I use MongoDB for some kind of application? I'll show overview of MongoDB applications. How do I create databases and implement the CRUD applications, create, read, update, and delete operations with the help of MongoDB as a case study at the end of this, the second part of the same sessions here. Okay, we'll be having a break at 11:40 a.m. and after 1 hour we'll start with the remaining session. Just to note that. So let us continue with the NoSQL databases. If you have any questions or doubt in between the sessions, that you can put in the chat box also. I hope you all learned about SQL database system. That is wherever you are using the structured query language systems. Whenever our data is present in the tabular form, in a table form, so we'll be using the structured query language like SQL, MySQL. You may have heard Oracle SQL, Microsoft SQL are there, where they're storing a data in a tabular format, in a structured format. And then we are using various queries that will be firing on that particular databases and retrieve the results easily on your system. So it is very easy, understandable to handle the data present in the structured format, because we know we are very much familiar with the tabular data there. But apart from the structured format, what are the other formats present that will come under NoSQL databases? Whenever data is not present in the structured format, that time we have to apply any one of the available methods. Many methods are there in the NoSQL that we can apply and use over there. So NoSQL means, originally its name was non-SQL, means opposite of SQL. They have given the name NoSQL, or it is not relational one. Relational means tabular data. So data is not in tabular format. It is NoSQL. Okay, which provide a mechanism for storage and retrieval of data that is modeled in means to other than tabular relations, as we are used in relational databases. When you have tabular databases, that time we have used data in that particular format, in the structured format there. Now, since the databases have existed since late 1960s, 1960s means the pioneer in the development of relational database was the Oracle. When they have released Oracle's second version, Oracle database second version, it was one of the great database system provided by Oracle, which is being used by many companies, and that's given the birth to a new term in the computer engineering, that is database management systems. Correct. But didn't last for almost for 30, 20 to 30 years. They were using database in the structured format only. So where are various databases developed by different companies, like Lotus 123 was there, then Fox Base were created, were become very much popular, but they were storing data into the structure format only. But the name NoSQL was coined by early 21st century, triggered by the needs of Web 2.0 companies, where they store data not only in the SQL format. That's why the name is not exactly the opposite of SQL. It's non-SQL. It is not only SQL now. And now today we call it as the not only SQL. They emphasize that they support SQL like query language or sit alongside the SQL databases in polyglot persistent architecture. Polyglot scalability, any number of data, any number of you can make it scalable to any wide range of application there. That's why it is polyglot consistent architecture. So not only structured but unstructured, semi-structured data can also be stored inside a database, which we call as the NoSQL database. That is common and general purpose definition of the NoSQL databases over here. Now, the motivations of these features. What are the motivations behind this? It was like they have to make such a database just simple in design, which contains horizontal scaling to clusters of machines. I want to develop an architecture which for few data is stored on one system, another system, another system, like it's called scalability, distributed architecture there. It is one of the prime reason to develop these systems. Or fine control over availability. Availability means it may be available multiple number of times or from multiple locations also may be possible. And limiting the object relational impedance mismatch. These are the reasons behind development of this particular architecture here. So data structure used by NoSQL are many. So primarily there are four different ways are present by which NoSQL databases can be created, which I mentioned here. We'll talk about that in detail. Key value pair, wide column database, graph and document based database. So they are different from those which are used by default relational. Relational common, that's why SQL is a standard language. SQL is a standard language which is being used to analyze, control, or communicate with the structured data there. Okay, which makes faster operations in NoSQL. So basically, NoSQL is not only single architecture. There are many architectures present, many ways present by which we can store data in a database. We know database actually, and that's databases of SQL type relational one and NoSQL type which is non-relational one. The particular stability of this given NoSQL database depends on problem that you are solving. Means many different problems are there, many requirements are there, where you have to store data in a systematic way, organized way. I'm not talking about structured way, systematic way, organized way. Fine. So sometimes data structures used by NoSQL database are also viewed as more flexible than relational one, because why flexible? Because they don't have any specific structure present to them. Specific structure is not there. That's why they are flexible. We can add anything, we can remove anything without wastage of memories there. I'll take one example of it when you see the detailing about NoSQL there. So there are various requirements today present. We are going to use NoSQL. Even data size is also growing. So it is not beneficial to waste the amount of memory. We can utilize the memory so effectively with the help of NoSQL databases. That's why they are becoming the emerging part of current data generation technologies here. Now see, there are four ways by which you can organize. I'll just give some names of databases which are coming under NoSQL categories. I mentioned already SQL standard. ANSI has standardized the SQL. So which database we can call SQL, which whose standards are given by ANSI, American National Standard Institute. Means what did they contain, the CRUD operation, how they are written, how aggregate functions are written, how programming language statements are written. The language, the software which follows all of these, they are called as ANSI SQL. So it may be PostgreSQL, MySQL, MariaDB, okay, or DB2 or Microsoft SQL or Oracle SQL, whatever. So all they follow the same, but in our case, we don't have standard architecture in NoSQL there, but there are many databases present which are coming under NoSQL categories. The first category, wide column. See, some of the popular key players present in that category, their names are given here. Azure Cosmos DB. I hope you may have heard about Microsoft Azure. It's a cloud, and these are the cloud-based databases. We'll talk about cloud-based databases also here in it. Accumulo, Cassandra. Cassandra is from Apache, open source, very popular one. Even HBase also, even Scylla also. They are coming under the wide column databases. Second, document databases. MongoDB is coming under this category, document-oriented databases. Azure Cosmos DB, Apache Couch DB, Arrango DB, Besex, ClusterPoint, Couchbase. Yeah, they are document based. Then key value paired based databases. I hope in Python you may have heard about key value concept in dictionary data structures. Similar kind of ideas are used over here. In this, Redis is very popular database. DynamoDB, Apache Ignite, Couchbase, Azure Cosmos DB. They're also coming under this category. And finally, graph databases, which is rarely used. Architecture is very great, but on a specific application is there where these graph oriented databases are basically used. Azure Cosmos DB is of that kind. Almost everywhere Cosmos DB is there. Algebra graph, ArrangeODB, Infinite graph, Apache's Giraffe, MarkLogic, Neo4j, OrientDB, Virtuoso. So the graph databases, these are currently being popular in the respective categories, and their architectures are different. According to their common architecture, the names are given to them. We'll talk about that architecture also in detail, how to do this one. Today, a very important advantage that we are getting on SQL, it is like they are used as a cloud, as a service now. Means we don't have to install that database in your system. We can use them in a online way through internet. We don't have to install it separately there. So these are the one which are given Microsoft, database as a service. In that Microsoft Azure SQL databases are there. Google's cloud SQL databases are there. Okay, they are SQL one. They are provided as a service. Okay, Amazon Aurora, Amazon relational database service, clusters, many are there. And similarly, the name which was seen before, almost all 100% NoSQL databases are running as a service. I mean, they are running onto the cloud. We don't have to keep separate installation. We can install it, many of them, but most of them can be used in online method there. Fine. So you can see the names: Amazon DynamoDB, Amazon SimpleDB, Azure Cosmos DB, Google Cloud Bigtable, Data Store. All they are coming under the database as a service category there. Fine. Amazon Document DB is also there. Service means their cloud databases are present. Cloud means they are available online. We don't have to download them. You can install, you can use, you can connect them in only online method. Okay, this is what current scenarios are. Means they are having capability to run as a service. If they are stored onto some central server, we have to use your authentication in a program to connect them, to store them, to use their data in your program there. That is what cloud-based databases basically contains. Fine. So 4 types I mentioned there. SQL contains only one, relational and analytical also similarly structured itself. No changes are made there. And 4 names are given: column, family, graph, document, and key value pair that are being used. We'll talk about them in detail, but let's see some primary requirements of NoSQL databases here. Let us compare. How can we differentiate between SQL and NoSQL? SQL, NoSQL, something. So SQL are relational. Data stored in tabular form in a single table, in a single structured data format. But in NoSQL, we have data stored in distributed format. It is not compulsory, but maximum databases which are being used today, they are stored in distributed form. Distributed means, see, I have a single computer over here, so it's a local storage. Means my complete hard disk is being used to store my database there. But what about distributed one? In case of distributed, means some data is stored on my computer, some in another computer, some in another computer. Means when there are thousands of hundreds of computers are there, and data is distributed among that n number of computers, because we don't have a specific structure to it. Any data can be stored anywhere. It can be replicated to avoid hardware failure, to get the data on time, accessible on time. That's the reason why data is basically distributed among n number of nodes, n number of clusters there. That is what done in the NoSQL database. SQL vertically scalable, means we can add any number of rows there, and NoSQL is horizontally scalable. Means their structure is completely dynamic. It's not a fixed structure schema present. It's called schema-less. Third difference I mentioned. SQL, we have specific predefined schema. Schema means structure. Correct. You use your query, create table name, and then structure you write. So you have defined a structure in your mind, and accordingly we have created in a query form over there. That is what we call as predefined structure schema. But in NoSQL, we have dynamic schema. We don't have a specific structure present there. So whatever requirement arises, accordingly you're going to store data inside it. So nothing is static there, nothing is fixed there. Everything is dynamic, and that's the reason it is scalable horizontally and distributable also among n number of nodes in a network. Then SQL, hierarchical data storage is not possible. Hierarchy means tree wise, graph wise, which is a perfect example of non-structured data form. I hope you have learned about the same in your data structures. Will you have the data in the tree format? That time we'll be using this method. Dynamic schema is present. correct? And here in NoSQL, we will be storing data in the hierarchical format. A spatial data format is present called as graph store. In that way, using that particular technique method, we can store data into the tree format in the graph format. That is what the fourth difference, and very important, the last one, uh, complex queries. So there are various technique present. I hope you have learned about it. Two terms: subqueries and joins. Okay, to join or to create a subqueries, they are complicated tasks. You have to write, consider most of the factors while defining the respective queries. Is accordingly that the results are retrieved to you and you can get that. But in NoSQL, it's not good for complexity. Complexities are not that much. They are directly having a function. Most of database are object oriented. It's like object is present, object table is created, and using the methods, functions onto it, I can retrieve the results or I can perform any other operations on it. MongoDB also coming under similar category there. These are the common differences between SQL and NoSQL databases. We can have many more also, but to differentiate between them, we can focus on these respective and very important points over here. Fine. Why do we use it? Let's go industry point of view. What are the technological changes are seen? And to fulfill that requirements, the databases are basically created. So NoSQL databases are used in nearly every industry. Almost means very rarely the companies are using structured databases. Maximum they are providing unstructured databases there. Unstructured, but organized, systematically organized. Remember, structured and organized is different. Organized is specific form format is present there. Organization compulsory hai, because if data is non-organized, so it is very difficult for programming language to read and retrieve the information from there or to perform any operation on that data. That's why they are systematically organized way. So use cases range from highly critical, means almost financial databases, healthcare records, they are stored inside these kind of databases there. Okay, healthcare records and all. That's possible. Okay, so use cases will be containing critical issues like storing financial data, healthcare records, to more fun and frivolous application like IoT readings. I hope you have heard about IoT. In Internet of Things applications, whenever data is read from the sensors, it can be stored in a database. It can be stored in a database, and from that you can retrieve it for any kind of operation. So there, large requirement of database is present, data store is present, and that is the reason we'll be using the NoSQL databases to store the data inside. So these are IoT requirements are very high. Wherever requirements are larger, we have to store data, maximum data with minimum amount of space utilized. There, NoSQL is basically being used there. Now see why we are seeing this particular concept very commonly. Reasons why it is emerging database today. Why we call it as a emerging database today. The first reason is data explosion. Now, now from last around 10 to 20 years, we have seen the growth of data is enormous, exponential in the world. So we are living in the data science world. Data science means something, technology which uses and lets us perform various operations on the data to find some novel insights from it. Okay, and data growth enormous. Like today we have 2, tomorrow we have 4, not 3, 4. Next day we have 8, 16, 32. Exponential growth is seen over there. So the rapid growth of internet and proliferation of data from various sources like social media. Almost everyone is account on social media there. Correct? Maybe it's a Facebook, it's a Instagram, it's a WhatsApp, or any other like Twitter, LinkedIn, or TikTok, whatever. So if 90% internet population is on social media, so how much amount data that may be collecting? Sensors, IoT application, they're running 24/7 to collect the data. And mobile devices. We are continuously active on mobile phone. They are also generating huge amount of data. So they created the need for databases that could handle large volume of unstructured and semi-structured data. So in our day-to-day life, we don't have any data which is structured always. Correct? We have unstructured data maximum, semi-structured also. So comparison is like 90% and 10%. 10% structured and 90% unstructured. So relational databases cannot store that. See, the platform like Facebook, Twitter began to generate massive amount of user generated content. Now, see this technology which you are using today, the way by which the data growth can be seen 20 years ago, 25 years ago around. What model was used for data generation? Where companies were generating a data and consumers were consuming it. They were using that data. Today it's different, inverse. Now users are generating a data and companies are consuming it. Is that, you know, that Google is knowing you better than you. Why? Because they are having every of your data with them. Continuous monitoring systems are being used there continuously. Correct. So that is why the vast amount of data is being generated there. Large amount of data is generated. And mobile applications. So smartphone. The rise of smartphone led to an explosion to mobile application producing diverse data types, different types of data, which is being your mobile phone. We are active on mobile phone 24 by 7. Probably. Correct. And that's why data is exploiting huge amount of data. So definitely in that particular case, with data size growing, definitely we should find a specific definite solution to store the data in effective way with a small amount of storage vested in it. That is the requirement. And see, many requirements are there which are elaborated in this particular diagram. Okay, faster development, partition tolerance, scalability, distributions, availability, high availability. Okay, query language, perfect query language, enterprise security management, flexible schemas, big data management. These are the requirements of current generation technologies, and very important to note, why do we use that data? Because data is the fuel of current generation technologies. Fuel. We are living in the world of artificial intelligence. What artificial intelligence requires? Artificial intelligence needs data to learn from. So they learn from data only. So definitely we should have a perfect, manageable, organized, systematic way to store the data. This is the first requirement. That's why we are emerging it. Now, second, many limitations that SQL databases contains. What limitations are there? Yeah, so traditional, we definitely they are limited with some specific kind of schemas there. Schema, only structures are there. They are limited with rigid schemas, which made them less suitable for application requiring flexibility in data structures. Flexibilities are there. Like let's take an example. Okay, I want to store information about cricket players in a table. So what I do, I'll define my schema there. Player's name, number of matches played, number of runs scored, average strike rate, number of balls bowled, number of wickets taken, catches taken, economy rate, average strike rate, number of catches, number of stumpings, like all. Is that? We'll have a table present over there, but make sure all of these columns are not applicable to every one of these players. Is that, for example, bowling average is not applicable to the one who is batter. Is that? Or number of wickets taken is also not applicable to the one who is not bowler. Number of stumpings is applicable only to the wicket keeper. So when I create a table, that field will be null, will be empty. Simple. So it is wastage of memory space. So RDBMS is not suitable in that case. We have to use such databases which can store the data in dynamic way. Is that? So data in dynamic way. So flexibility is not present. That's why you have to use. This is limitation of SQL database basically. So they are just wasting the memory space over there. Their performance could also degrade under heavy loads, particularly when read-write operations are performed. See, there's a property ACID, you may have heard about ACID: atomicity, consistency, isolation, durability. These problem are present over there. Some databases are not providing this isolation or read while read write operations are performed there. Advantage and disadvantage both are there. Rigid schema. So traditional SQL database required a predefined schema, compulsory, making it difficult to adapt changing data requirements. What will happen is, for example, if currently I have data of some student, let's say from last 10 years data is present there. Now today, if new column is added inside that table to add new entries, like for example, when college was started in 2000, from 2000 to 2010, there was no any Aadhaar card number present. But now 2011 onwards, they got Aadhaar card number. Now they have to add one more column for Aadhaar card number. What about the data which is present before 2010? They were not having that. So, but column will be present for them also, which will contain null entries. Correct. Wastage of memory space. Okay, so it will be difficult to adapt the changing data requirements. Rigid schema. Second, scalability issues. Yes, and scalability means growth of database, because data is not static, it is dynamic. It's dynamic, means any number of entries can be possible inside it. So as application grow, relational databases struggled with horizontal scaling, leading to performance bottlenecks. That is the problem. So scalability is the way by which you can store data dynamically without worrying about the storage capacities present there. So you can distribute them n number of computers. Even we have to make it replicated also, like that. These are the scalability issue which is not possible in relational database management systems, SQL. Now see, there are two architecture basically being followed: scale up and scale out. Two architectures are there. What we exactly do? See, scale up means here this hard disk is stored. So if I am storing data in 100 GB drive, and my data requirements are grown, so I'll change my drive to 100 GB to 1 TB. More RAM, more CPU, more hard drive. What I'm doing, I'm replacing the hardware which is being used over there. And what about the scale out architecture? Yes, I'm keeping OLED as it is, but adding more and more number of hard drives, CPUs, RAM to it by keeping original one as it is. This is exactly architecture we are using today. Scaling architecture which are using today in current generation database management system, which is being supported by SQL, NoSQL technology. SQL doesn't have this scale out kind of architectures there. Okay, because of rise of big data, we'll talk about that also. Big data, we are adding, we are taking advantage of scalability concept from the big data management here. That is scalability. Next, scalability needs. Yes, as web application grew, there was a demand for system that could scale horizontally. That's good. Scale horizontal scaling. So horizontal scaling means I want to extend the number of columns. Let's say individual entries I'm extending, maybe increasing or decreasing, whatever. So NoSQL databases were designed to distribute data across multiple servers, allowing for more efficient handling of increased traffic and data volume. You see, take any example of it. In current generation world, whatever clouds are available, whatever data platforms are available with us. If you take a Google Drives example, see, Google is providing 15 GB free space to us. 92% internet population is there on Google, and everyone is given 15 GB free space. Myself is having 5 account on Google. Out of the 2 professional, where they are providing 200 GB and one is 60 GB. Okay, and maybe such accounts are possible there on Google. So how much amount of data that Google is having with them? Think about it. If I want to increase my space, I can do that. Scalability is actually data stored in distributed way, multiple methods among n number of clusters. As traffic is growing, data requirements are growing, you can extend it. They are using this architecture without affecting the speed. That is the advantage of scalability basically, because application can run parallelly on different computers there. That's why the speed doesn't get hampered. Scalability will be implemented perfectly there. That is why the SQL is now emerging. SQL contains this feature present today. Now, yeah, very importantly, NoSQL can be used in variety of use cases at various different applications. I can apply and use it there so effectively. The developers began to explore different type of data and access patterns, because in last century when SQL was used, there are traditionally they were stored data into the tabular form, and there was no difficulties and flexibility was present in handling the respective data. Now, by NoSQL, it lead to create a specialized NoSQL solution tailored to specific use cases such as real-time analytics, content management, graph data modeling. Various are the real-time analytics means live data analysis, where I can get data in distributed format and perform the operation of analysis on live data, online data, live data. Content management, CMS, content management systems, where they are like website can be designed by using the CMS there, and they are having a database present. We don't have to worry about what pattern database contain. We just can connect them and use it directly with them. Graph data modeling, where data is stored in graphical format, tree-wise format. So there are various use cases where we can apply and use it there. See this. Various companies we can use in variety of applications. Real-time data to application uses business processes. If you take in retail stores, there also they are using database as a backend. No SQL database as a backend. Real retail applications, retail recommendation systems, product catalog storage management, real-time order processing, inventory management. Okay, see the examples given. They are using that. Then in FSI, mobile banking applications, real-time transaction, mobile payments. Okay, personalization, customer personalization, credit card, real-time fraud detections. Like all, they are using AI ML algorithms also as a backend. Then in manufacturing and utilities, manufacturing means automobile companies or mechanical industries. They're also using real-time IoT telemetry injection. Like we are currently living, industries are in fourth revolution, industry 4.0, where they are empowered by data science, AI, and IoT applications. So they require IoT telemetry to do automatically. So they require data to be collected continuously, 24 by 7, second by second. So that's done by the NoSQL databases there. Real-time supply chain management, real-time order processing, okay, predictive maintenance, remote monitoring system. The great application. Predictive maintenance means when this machine will fail, that you have to predict first. Data is generated continuously 24 by 7. Accordingly, they can predict. Or remote monitoring, without physically locating at that location, we can monitor the things remotely by controlling it through databases. And very importantly, healthcare sector, where you can use lot many applications are available in healthcare. Real-time claim processing, modernizing legacy application, unified disparate systems platform, like all. Or real-time monitoring of health, where data stored, health databases are created, data is stored over there. So almost everywhere, in all emerging areas where data is has become a primary requirement to store, there the NoSQL are used. Now, big data movement. So big data is something which is containing large amount of data. I hope you may have heard about this name. The data which is in huge amount, and it is very difficult to manage that data with the help of traditional data management systems. That's called as big data. Big data, correct. So rise of big data technologies and framework such as Hadoop, we'll talk about Hadoop now, highlighted the need for databases that could integrate seamlessly with data processing tools and handle large data set efficiently. Now they are using distributed system mechanism actually, which one Hadoop uses. In 2006, Hadoop was introduced. Today is being one of the primary technology for handling data in huge amount. So introduction of Hadoop provided a framework for processing large data set across distributed computing environments, highlighting the need of databases that could integrate with big data solutions. So Hadoop works on distributed data management only. Maybe if you learned about it, they are using distributed management, HDFS, Hadoop distributed file system, distributed data among n number of nodes clusters, and then execute the MapReduce algorithm on that separately, execute them, generate the result, and generated result is combined at central location on a master computer. That is what basically Hadoop does. Okay, this big data movement. Under big data, you can see this Hadoop is a framework which does this particular work of handling, managing the complete big data architecture over here. Complete big data architecture is handled and managed by the Hadoop systems here. Now you can see this one. This is Hadoop's ecosystem. Ecosystem contains all tools, technologies required to handle the big data. See, so Hadoop combines all together. It's one of the primary tool being used for big data management. Second is also there. I'll talk about that Spark. See this one, MapReduce, which is used for data processing, Hive, which is used for data warehousing, SQL type technology, Mahout for machine learning, Peak for scripting, and H-based NoSQL database. It means as a part of big data management system, we require NoSQL also. We require SQL also, we require NoSQL, both are also. H-based is NoSQL, Cassandra NoSQL है, Couchbase है, CouchDB है. They are used over there. And along with all other technologies are there. Okay, Kafka, Spark, Sqular, Lucene, Uzi, Yarn, HDFS, Apache Ambari, Apache Airavat, many are there. Okay, Flume, Scoop for data management, like all they are. Among them, one of is NoSQL. You can see its name is given here, Apache HBase. So whenever data that we manage, we store, we handle, especially in NoSQL format on huge amount of data, big data technology, that time we require a NoSQL databases. So data size is growing enormously, volume, variety, velocity of data is growing, and the technique, organization method which is suitable for that, that's what we require, and that is satisfied by the NoSQL there. This is first. Now see, when I combine them, real-time big data is equal to operational data plus analytical data. Okay, operational data, analytical data. Real-time data we handle by using NoSQL, and batch-oriented analytical database we handle with the help of Hadoop. So they are combined together. The features of NoSQL, that is operational, and they are online. That are velocity. Data is flowing. And Hadoop will be used for analytical work and handling large amount of data over there. Correct. You combine them together. So real-time big data analytics is done in coordination with this big data technology and NoSQL. And that is the reason why NoSQL is being emerging today. Okay, NoSQL's first advantage is online. Okay, they are working in distributed fashion in online network-based method. They can be integrated with web applications, mobile applications, IoT applications, and very importantly, millions of customers or consumers are present, which are anonymously using NoSQL as a backend anonymously, and we don't know what database they are using over there. Correct. So to perform real-time big data analytics, it's required to have a database store that is satisfied by the NoSQL technology here. Fine. There's one more technique, one more framework which is being used here in the big data analytics, and that is Apache Spark. Is the name Apache Spark. Now this Spark basically is an in-memory processing operation. It means whenever you have to handle huge amount of data, it creates the data structures inside the memory, inside the RAM, and then uses it, handles it, and accordingly generate the results from it. That is what Apache Spark does. And Spark is having ability to handle all kind of database, whether the SQL, NoSQL. You can see Postgre, MySQL are coming under structured category. Redis is NoSQL, MongoDB NoSQL, Cassandra NoSQL, H-based NoSQL. You can use the data on them. Means all integration of big data technologies, whether it is from Hadoop point of view or Spark point of view, they can use NoSQL inside it to store huge amount of data, multi-billion terabytes of data, petabytes of data. They can handle, they can store in a distributed fashion among n number of clusters. That is the advantage of big data technologies, where we can integrate NoSQL technologies, something by using this method. Then cloud. Yes, one of the primary reason why do we use the NoSQL, why it's emerging there, because of cloud system. What is cloud? A common definition the persons are having in mind. Okay, cloud means a data storage where data is stored centrally. It's okay, that is correct. But that is not only the cloud. Cloud is something which you can access through the internet as a service. Correct. You can see this example. It's a cloud. Cloud means this infrastructure is created locally, sorry, remotely at some different place. That we call as cloud. What infrastructures are there? We have servers, we have virtual desktop systems, machines, computer systems, software platforms, applications, storage devices are there, and we can make them use in our system through the internet. If I want to store a data, I can make use of internet to store. Let's say Google Drive is a cloud. Data as a service. I don't have sufficient amount of storage in my systems. I can use a Google Cloud to store data over there. That is data as a service kind of cloud. Where do we store data onto the cloud? Storage. Applications. For example, I hope maybe if you heard about Google's Collaboratory, it's an application. It's running onto the cloud. I don't have to download, install it. I can log into that. I can use it there. Cloud. Software platform. So I can run any software over there. Like design softwares are there. Like for example, Canva. Canva is a cloud software where they are running application on their server, but I'm just handling through the user interface there. Software platform. Virtual desktop can be taken, like Amazon's EC2 can create a virtual desktop environment. Server environment can also be created there. So we can make use of internet to access them. Now, it is not required to install database, because our storage, though we are having in GBs, our storage requirements are still growing very fast. If I'm collecting data from a system 24/7, definitely after 1 month, 2 months, 3 months, 6 months, 1 year, our storage capacity will be over. Now, where do we store data in that particular case? So we should have capability to store data onto the cloud or use database as a cloud itself. Just like example I've given in the previous slides. Okay, I want databases to have a capability to run onto the cloud. So I don't have to install them. I can use my credentials, my username, password to log in there. I can store all of my data on that server, on that location, on the cloud, and integrate with my software application which I have created as a front end. And in back end, I'm using a cloud database there, which is not possible directly by SQL, but SQL contains scalability problem there. But as I want to satisfy my requirement, I can use my computer, my desktop system to integrate database without worry about installation on my local system. I can use a cloud, that is cloud computing systems. So I can use any desktop, my laptop or mobile phone to connect with them. But I should have internet connected there. Then only I can access and use this cloud architecture. My cloud is enormously growing from last 15 years. See, one simple statistics I'll show. Key nearly in 2013, 12 or 13, total 17% companies were using cloud services that time. Today, 67% companies are using. 50% growth we have seen from last 11 years. Companies who are using cloud services, cloud systems, they are not caring about installation of the softwares on their platform. So they are providing the services online. Installation of that service, security, privacy of that service is taken care by cloud service provider. For example, Amazon or Microsoft. They are taking care of this. That is what advantage of cloud computing is, and clouds are growing definitely. So companies are giving the platform to use NoSQL databases through the cloud without installation of them on my system there. That's what the cloud computing basically does. So the growth of cloud infrastructure enabled deployment of NoSQL databases as managed services. SQL as a service. NoSQL as a service. See, anything as a service is a cloud. Like there are various different architecture of cloud are available. Software as a service, platform as a service, infrastructure as a service, data as a service. Like many services, design as a service, encryption as a service, login as a service. Many such architectures are available, which we can use here onto the cloud system architectures. That's why they are emerging. And that's the reason why NoSQL is being developed, used so fast in current generation software technologies here. Fine. Now see the cloud database. I have given this name before, but as per the architecture, the technique, the way by which they are created, AWS, Amazon Web Service, one of the most popular cloud in the world. Then Google Cloud, and third is Microsoft Azure. So in case of Amazon AWS, document databases are document DBA, key value pair DynamoDB, and in-cache memory storage is MemoryDB. Cloud available on Google, Firestore is there, Bigtable is there, memory stores are there on cloud on Google, and from Microsoft, Cosmos DB, Cosmos actually, table storage, cache, and many are there. Lot many databases are provided. They are having their own query language with the help of that we can interact with them. They are the cloud databases. I mean, they don't, their local version not available. We have to avail them online by logging to Amazon Web Services. Log into Amazon Web Services. There you can use it. Download the cloud databases. Fine. Next. Now, in 2010 onwards, now though NoSQL started at the start of this century, but from 2010 onwards, the actual usage of cloud is nearly undertaken by the different tech giants, which are that companies like Google, Amazon, Netflix adopted NoSQL solutions to handle their vast and varied data sets. Vast and varied data, whatever. So they were having huge amount of data. So to manage that systematically, most important organized way, they started using the NoSQL technologies here, tech giants. Okay, where now they are having managed services, where cloud providers began offering NoSQL databases, managed services like Amazon DynamoDB, Google Firestore, making them accessible to the broader audience. Because how it's made accessible to a broader audience? Because on the cloud, central, on internet, they are available. So anyone can use their credentials, that is username and password, to log in to access the data. That's why 2010 onwards, these companies have started using these technologies in their software development there. And if I see current scenario, let's say this decade, 2020 onwards, technologies have become mature. So the MySQL databases have continued to evolve with improved features or consistency, transaction support, and integration with machine learning and analytics. Correct. We have seen big data architecture there in Hadoop. So this architecture contains separate services to accomplish a respective task. In that, we shown Apache Mahout was there, Spark MLlib was there. These tools, these platforms are basically used for implementing AI machine learning algorithm primarily on the data and in coordination with NoSQL technologies. Correct. That is the first one. Currently, if you see current generations, analytical method, predictive analytics, descriptive analytics, diagnostic analytics, prescriptive analytics, they are done with the help of is inbuilt algorithms of machine learning there. Today, 2020 onwards ahead. Secondly, there are many companies now started using hybrid approaches where we have simplicity in design and usage in SQL. When requirement is perfectly satisfied by SQL, then SQLs are used. If they are not, then no SQLs are used. So many organizations are now using a combination of SQL and NoSQL databases both, leveraging each type of strength based on specific use cases. Many today, almost 50% plus companies are handling using the combined approach for SQL and NoSQL. Both are there. This is a new trend and technology being used. So that's why if you want to be the part of data analytical work in companies, so make sure you're having good knowledge of both SQL and NoSQL. NoSQL is okay. NoSQL is not traditional one, and there is no standard method used by everyone. But the one which are very much popular, whose study, understanding, practical we can do, so you can get an idea how NoSQL basically behaves, how NoSQL basically works. That's so ecosystem is evolving 2020 onwards with machine learning technologies and hybrid approaches, which is being followed. And that is the reason why NoSQL are now emerging, NoSQL are now growing. The way which is being followed there is systematic and most beneficial to the growth of technological development under data science here. Now you can see this one. This is taken from Data Intel Law. See, the market outlook from 2024 to 2032 is given here. Global size forecasted 17 onward 23 is shown how growth of databases are there. The figure representing global market size and forecast from 2024 to 2032 they are shown over the current database. Now 2017 to 2022 are where the historic years. 2023 is the base actual year and forecast provided from 2024 2020 32. There how the market outlook will be there for the SQL based, no SQL based technologies here. This you can see. And if I check, if I compare the growth of these technologies from SQL point of view in comparison with the SQL, then how it is basically stored, that you can see. See here. The new stack has given this scenario. So on x-axis, the years are given. Okay, their growth on 20 was shown, and on the y-axis, the popularity changes are shown there. Popularity changes are visible. Now you can see there are 4 lines are shown. Document store databases, which is very much popular among all of these 4. Second, key value stores, whose growth you can see. Their linear growth can be seen. And third, wide column databases, which is declined at around 2020. See, and the red one, relationally, which is not growing, it is stabilized but not growing. Stabilized almost around at 100 plus. Correct. Linearity is not there. Stable. But the NoSQL databases are continuously growing linearly. I hope maybe knowing linear growth is like in a straight line, and almost 90% are linear. Even today, we can predict in next year how the growth of that NoSQL database is possible. I can definitely identify that. That's why they're emerging one, and that's the reason why being used very commonly in the companies over there. Fine. Now, if I want to store this data into the databases technically, so what type of data are present? 3 type of data is present in the computer systems, and then we'll see which models, which kind of models I can use to store this data into the data. First is structured data, which we know, which we have handled already. So often number of numbers or labels stored in a structured framework of columns and rows relating to preset parameters. Like I want to store data of students, so I'll have roll number, name, class, marks, age, like all will be there. Table. So codes in databases like SQL contains it, numbers, database, Google Sheets that I can store. Second is semi-structured data, where data is stored in a tagged way. Tags are basically meta tags are used. I hope you may be knowing XML file format. Semi-structured. It's not organized in a table, but it's a structured format basically. So loosely organized into categories using meta tags. Correct. XML format, JSON file format. Not 100% it is semi-structured, but semi-structured you can say. Emails by inbox, send, draft, tweets organized by hashtags, folder organized by topic, like all that we can have. And the highest amount of data available today in a detailed form, it is unstructured data. The third one. Correct. So text heavy information that is not organized in a clearly defined framework or model. It's called as unstructured data. Media post, email, online reviews, videos, images, speeches, sounds. There is no specifically structure present. Structured organization is there, but structured is not present. So we can call it as a unstructured data. So these 3 kind of data can be stored in a database. But which models I can use, which kind of ways I can follow to store the data, that it actually comes from the aggregate data model concept. Let it come from aggregate data. What is aggregate data model? Now, aggregate data model is a way of organizing and structuring to capture related information in single cohesive unit called as aggregate. Means it may be any kind of data. It can have structured, unstructured, or any other. So we can have a single cohesive unit aggregating together. Like we maybe have heard about, may have heard about the concept of data warehousing. Data warehousing is a way to aggregate the data center location by following a systematic approach there. This approach is especially common in NoSQL databases and domain-driven design. Domain-driven means for healthcare specific domain we can have this domain healthcare and you can design the database accordingly. Fine. And these aggregates are designed to represent a single concept or entity within a business domain and treated as a single unit of consistency. We can design them. Aggregated data center location, not like that raw data structure I've created. I'm taking everything in a bin, bin kind of things. I'm taking everything, putting in a bin, getting bin, connects with bin, combine. It's not like that. We have to follow a systematic approach to do this particular work. Now, what do you mean a cohesive unit, which I mentioned before? So, cohesive unit means it aggregate the bundle related data together, representing a single business concept or entity like order or user profile. For example, on a website, I want to create a user profile. So, what technique should I follow? What data should I collect? User profile. That's a cohesive unit. On order, if I received an order from a customer, so which kind of information should be present inside it? That is cohesive unit. Second, encapsulation. We know, I hope you are knowing that in object oriented programming, you have heard about this. Aggregate, encapsulate both the data and behavior. Data is there. Data is known to that particular entity only, which is encapsulated. It's like it's a capsule over it, but data present under it is not visible to the external world. But an encapsulation. How to access then? So we can follow the technique of behavior functions to access the data, promoting better organization and clearer boundaries. That's called encapsulation. And third, identity. Okay, actually five are there. So third is identity. Each aggregate has a unique identifier. Definitely they are required. That allows to be tracked and referenced. This ensures that all operations on the aggregate are coherent and maintain the integrity of the data. Okay, definitely. Because I want to identify, like let's say I am having thousands of orders in my company. So every order has given an order number. That order number is the unit identification of the respective order there. It's the identity of it. That will be present inside the aggregate data model. These topics are required to get considered while designing the data models there. Now, inside it, few things the developer have considered. Means I want to store data systematic way, organized way, but in non-structured way. So for that purpose, aggregate data models are used. So the things that are considered first is consistencies. Changes to aggregate model are treated as a single transaction, ensuring that data remains consistent within its boundary. This approach helps to manage eventual consistency in distributed systems. We know what consistency is. Asset property contains it should be consistent in a systematic, organized way when transactions are being performed on the database. Second, data denormalization. In many SQL, NoSQL implementation, data within aggregate is often denormalized. We know what is denormalized. We know normalized in databases. Normalization is like systematically organized data in separate database data tables there. Denormalized means combining together to form a common table which contains all kind of data inside it. It's meaning that related data is stored together rather than spread across multiple table or collections. Correct? Combine single denormalized. This reduces the need of complex joins. We know that why do we use join? Because data is present at different tables. Then you have to join them to combine a common result from there. And second is to improve the performance of the system, reading performance of the system. Their aggregate data model uses. Now, there are various components present under it in aggregate data models. This is common idea. When it is actually implemented, there are different data structures are used that I will elaborate now. Aggregate is a fundamental unit of model representing cohesive group of related entities called aggregate. Combine all together, everything. Like in an in a program, we have some n number of objects. Every object is a aggregate. Second, root entity, where it is exactly started. The entity within an aggregate that is responsible for aggregates life cycle and consistency, where actually data model started root. Third, value objects. Now under this root, multiple objects are there present. Immutable object. Immutable means they are not changeable. Their content you cannot change. That represent attributes of aggregate and do not have their own entities present in it. Fourth is entity. Entity means value, variable. So mutable object with an entity that can be referenced independently is called as entity. And finally, domain events. Event means operations. Event that can occur within an aggregate and can be used to trigger actions or updates in other part of the system. That's called a domain event. So these are the component present in the aggregate data model. Using that, the data models are represented. You see this one. See, normalized data, which you can see like that. Book, album, genes. Under album, we have the tracks. Under track also, we can have again many different things are possible. Deep, normalized data in different tables. But in aggregation, we can define everything together as a separate product. You can see. So product is a book, another product is album, another product is a genes, and under it we have defined all of the properties. They are linked together. Aggregating all of them in a single defined architecture, that is called as aggregate data model. Fine. Common architecture. There is no any special method which is being followed, but different systematic ways are possible there. The first way which is shown over is relational. The second way is non-relational. Aggregation way, non-relational. Another different way which is being followed there to store the data, which has given birth to the NoSQL data store management here. So see the example of it. Now in aggregate, our root will be order. For example, order aggregate. Okay, I want to store information about the orders given by a consumer or customer to the company or client to the company there. So what they will contain? Your main root order. Under it will have attributes. Which attributes? Order ID, customer ID, order date, total amount, whatever will be there. And related entities will be order items are there. Product ID, quantity, price altogether. Then we'll have shipping address. Under that again entities will be there. Street, city, state, zip code, phone number. Then payment details will be another entity. Payment method, transaction IDs, amount of money, like all the way by which they are used, like all these things will be together present. In this way, systematically organized in the order aggregate. Remember, and using this particular item is once you identify what is your aggregate, what are the entity, what is your root, I can define a perfect way to store the data. A perfect way to store the data. And these ways are many possible. What's the advantage of this method? Why do we use aggregate data model? Simplicity in design. Because I don't have to store data in the raw form. It's coming, stored. It's coming, stored. It's coming, stored. Continuously store. Done. So it simplifies the data structure by bundling related data together, making it easier to manage and understand. Easier to manage and understand. Simple, eh? Very simple. All data is bundled together. Second is performance. Yes. Reduces the need of complex queries, joins, leading improved performance, especially when you are performing read heavy application. Data is very huge about that time. And third, maintainability is easy to maintain. Changes can be made to the aggregate in a controlled manner. In a controlled manner. Okay, improving maintainability and reducing the risk of data anomalies. Okay, reducing the anomalies over there. Just remember it. So these are the advantages of using the aggregate data model. Where do we use it? E-commerce platform. These are the applications of NoSQL actually. Managing order, shipping cards, user profile, content management systems, storing articles like content management system, website, bloggers, websites, comments, their user interactions. Okay, data that you upload, file that you upload, everything is present in CMS. And third, event sourcing that many locations are. This aggregate data model has given the birth to the ways of storing the data in the NoSQL databases, storing the way into the NoSQL databases. So which are that? Which methods are present here? Now you can see the names. Within NoSQL system, there are multiple ways possible to store and retrieve the record that surpass the limitations of relational systems. The primary ways where NoSQL can include are these one. Key value store. We have seen that already in previous session, previous presentation, I have shown that what are the ways to store the data in NoSQL. So first thing, key value store. Second, a document based store. Third is column based store. Fourth is graph based store. Okay. So means that the commonly four ways are present by which you can store the data into the NoSQL databases. These are the four primary ways present by which it can be used to store it. These are the storage architectures possible which you can use here. Okay, so some NoSQL databases work with more than one type of record store possible because at the start I have shown on one of the slide of database service I have shown that we have key value store, what database are there, document store, column store, graph store. So different ways by which you can organize. The aggregate data model has given the birth, the ways by which data can be stored in systematic and well organized way. Now let's see one by one. What is the use of it? How can we store the data by following a respective storage architecture in SQL? So we can define there are four ways possible in NoSQL to store the data. So as per the data that you have collected, you can choose a respective mechanism, respective way, defective to storage architecture to store the data inside it. First, a key value store. Key value store. Now, the key value store database system that store records of unique identifier with an associated value present in it. Okay, with an associated value present over there. So data pairing is referred to as a key value pair. What is key? Key is a unique identifier, and value is the data that is being identified or its location present there. Is that key value pair? I hope in Python you have heard about this term, dictionary that we can use. See this, for example, if I'm using something like this, so see here in this architecture, this is Python's terminal. Okay, now see this key. I have created something like x is equal to key value pair a, or we'll have some numbers 1, 5, then 6. Okay, and then we have a a for apple. Now see this is x, and this x is a data structure. We store data into key value pair format. 1 is the key, 345 is the value, 5 is the key, 27 is the value, 6 is the key, 231 is the value, a is the key, apple is the value. So this key and value can be of any type. If I want to access that value, I can use a unique identifier, and that is the key over here. See this. If I use x of 5, 27 is accessed. X of 8, apple is accessed. If I want to change it, I don't want the a to be there. I don't. I want to change the 6. 231 is given. I want to write a name database. Now see. So X has changed to database. Easily it can be changed. Or if it is not present, like I want to add one more key value pair Z in that X variable. and I'm putting zebra there, so it's added at the end. So if it is present, we are replacing it, and if it is not present, we are appending it. It's called as key value pair kind of system. So, and make sure it is not dynamic. It's not structured, not structured. Any value you can add, replace. Key value pairs, which we can integrate inside this. And this technique is called as the key value pair way to store the data inside the NoSQL database here. So NoSQL database can store in this particular format, which is called as key value pair database. Fine. So checking this. So major benefit of this key value store is that they are fast for data retrieval, because we have seen that when you get fast the key, directly access data from that particular key. Okay, where relational systems store data in across rows and column need to query across the database to return a record. Key value store is more flexible, has to search for the key, then return the associated value from there. Not only search, but replace operation also done very fast. And not only that, even create, read, update, and delete, all four operations have become faster. When your associated key is perfectly known, you can perform the operation so easily on this particular data store pattern. That's called as key value pattern, key value way to store the data inside a document. You can see this one example of this. The key 123, a value 123 main st 126, and these values are there, and it can contain any key of this value. Means under key also you can have one more key store, something like that. You can see key customer id, under it we have value object, under it we have customer billing address, under it we have another key value pair order, under order we have shipping address first key, order payment second, order item, and under it we have product. Like all inside we have the pairs of key values present in it. Fine. Key value stores which are possible in it. Fine. So due to the speed of return and their flexibility, so I've shown that one there. The key value store are particularly useful in certain cases such as storing, recalling, and updating product information, pricing, categorying, and other e-commerce related functions are possible with the help of the key value store over there. Then second, storing user details, preferences, session information, and for rapid call management, rewriting the data. All because here speed is becoming very essential aspect of performance of system. There we are using it. Generating real-time data that provide relevant advertising as users move through different areas of platform or website. There we use it, key value store. Okay. Yeah. Second method, document-based store. Now, what is document? Document is like a file, storage, physical file where you can store the data inside it. So another storage option is that document store the data in a semi-structured document. Data can be then ordered with markers. What file formats are there? That document is stored where there are very four popular file format are chosen to store the data. What are that? XML. Second is JSON. Third is BSON, and fourth is YML. And definitely, if you see this, I'll show that. If you've seen that, this data is not structured. There are various ways present that we can use it over there. They are not so possible to store in a table, and this is why it's unsuitable for relational storage. Instead, complex data set are contained in a single record. Means document store can store these kind of document directly inside the database. Either they can use XML document to store, they can use JSON document to store, BSON document to store, or YML. XML means extensible markup language. Okay, XML root format, from that itself the HTML is created. Okay, markup language is being developed. Semi-structured format, unstructured also. JSON, JavaScript object notation. This is also very much popular format being used today. And general, if you see current ideas of JSON, they are similar to key value pair kind of format is, but that is a document directly we can store. Just a file content, that file directly as it is we can store in a RDBM, sorry, in a document store database is there. Listen, binary JavaScript object notation. And last day YML. YML is some interesting. YML are not markup language, something kind. So that is there is special format present there. That document also you can store in a database document store. So retrieval occurs when key is used to locate the document. Actually, the documents are given some unique identifier. A unique identifier can be used to retrieve the data from the document store databases, and then the document is searched for information required. See this. This is JSON file format, JavaScript object notation file format. Key value pair, na? Correct. It's like a dictionary, but they are having ID associated with them. That ID can be used to access the data from this document. Document of document is also there. See there, social media accounts are shown. Under it, type Facebook a username, something is given. Type Twitter a username, something is given there. Correct. They're called as document store. This is JSON file format, which is being used by MongoDB. When I show the MongoDB operation that I will show you, this format we can directly choose to store data inside the database. Okay, it's called as document store. This is XML file format. See, XML. I hope me may have heard about this. XML is a markup language format. It's just like HTML contains. HTML itself is created from XML. Event. Top root entity. Under it again event is there. Another small event. First event MTWTF week. Second event contains SMTWTFS. These are the short names of your week days. Okay, then under start time end time playlist again under it you can have like a hierarchical kind of system I can have, but systematically I can store SQL data also inside XML file. This is XML file format to store the data. Second, third, YML. This is YML file format. Aggregate data model exactly contain the YML file format, something like this. Dataset root under via ID, first name, then title, second, summary, project, under it again two are there. Again creator, under creator we have another name, email, its value, name, its value, URL, its value, something like that shown over here. Publisher, under publisher we have email, name, then URL, like all. This is YML file form. YML aren't markup language, that's full form. So if I want to store this data directly as it is inside a table, that's called a document storage. MongoDB is coming under this category, where they store JSON file directly inside the document, directly inside the database. Remember, that is document storage for. Yeah, see, if I compare them, you can see this like same data. If I am storing in different file, YML, you can see API root. Then under we have name login, we have port 8080. Under your name profile, we have port 8090. YML. Then XML. XML contains the tags, meta tags are there, which you can use to store data there. Fine. Meta tags can be applied in XML. Then JSON. JSON contains key value pairs, but they contain the array also, they contain list also, they contain set also present in it. APIs are two set of APIs are there under this name, login, port 8080. Then again name, profile, port 8090. Save data stored in three different kind of file formats. Any one of them will be chosen to store this document directly inside a database. It's called a document store. And one more thing, it's not compulsory that everyone should have same. So if my table name is APIs, then my column name and name, port, login 8080, profile 8090. That table is created, and this table is implemented in YML, XML, and JSON. But here advantage is that Not, it is not compulsory to have the name and port every time. For one will can only name, port is not there. Or we'll have name, port, and operation. Three things are there. That is also possible. Correct. Anything is possible. They call document store can contain any of these methods dynamically, not compulsory. They should have the same data present in it. No. So MongoDB uses data in this particular file format. Storage architecture there. Advantage. The benefit of document store is that different type of documents can be contained with a single store. Yes. And updates to those documents do not need to be related to database. Relations are not mandatory. One document one type, another document another type, another document of another type, that we can use, that we can apply there. That is what they contain. It's not compulsory that data should be of same type. Data can be of different type. They are possible over there. Okay, because there are no fields within the store, and therefore no empty cells or missing records are possible. These missing records. Fine. Empty cells are not there. Fine. Documents are incredibly efficient, returning data fast. Every document has assigned with a unique identifier there that we can use. Fine. Now, the document sources are highly useful when they are working with JSON, BSON, XML, YML file. First, second, you need to make changes to your data schema often. I need to make the change schema in the sense that I want to change that document architecture there. There we use it. Second, third, when you're working with unstructured or semi-structured data, see XML semi-structured format that we can use. Third, when you need something simple for development, this is simple. This architecture is simple actually. It's as per our experience. Simple form architecture available there. So document stores are flexible, easily scalable, and developers can work with them even without prior knowledge system. Again, identifiable, a simple identifiable. If I compare them with the SQL storage pattern, so they are almost similar kind of architecture. Only the thing is they are enlisted in a hierarchical way over here. Enlisted in the hierarchical way, that is document store contains. So many of them are possible. Whenever I want to actually work with this kind of data structures, will be following document store based systems here. Fine. Okay, so as I mentioned, we'll take a break now. From now onwards, 1 hour. We'll start at 12:40 onwards. Remaining topic, a few more topic related to MySQL are NoSQL are remaining, that we will continue, and the MongoDB's demonstration also I'll show you at the end. Yeah. So thank you. We'll start exactly at 12:40 or 12:45 somewhere.